section 6.4, and we've reached the last section of chapter 6. Congratulations! This section takes a look at how we can solve trig equations using identities. Remember how I said all that stuff from chapter 4 is going to come back? Well, it's back again. This time we're solving trig equations, and we're going to extend what we did in chapter 4 to throw in the usage of identities. Alright, so you thought chapter 4 was hard? Well, it was. This section is probably just as hard. Remember that special angle table? Yeah, all that stuff, that comes back again. Okay, I've got, once again, the summary of all the trig identities for you. And you can use this as a reference as we go forth to try to solve these questions. Okay. Once again, section 6.4, just like 6.3, pretty easy when you watch me or listen to me do it. It's another story when you try it on your own. So please, please, please put some effort and try this on your own. Okay. Here we go with example number 1. We're going to solve each equation algebraically over the domain of 0 to 2 pi. So we're looking at radians, okay? Remember that good old special angle table. That will come in handy for sure. Now, in example 1a, notice we've got 2 different trig ratios. In chapter 4, we only dealt with 1. So I think our goal here is to try to rewrite this with only 1 trig ratio. And I'm thinking cosecant, I want to quickly rewrite as 1 over sine theta. That equals to 2 sine theta plus 1. Don't really like having the denominator of sine theta, so I'm going to clear the denominator by multiplying by sine theta. Or some of you, when you learned rational expressions in grade 11, were told to rewrite all the terms with sine theta as the denominator. And if we do that, what we're missing up top is another sine theta, which becomes sine squared theta. And then the 1 just becomes sine theta over sine theta. And so when you've got the denominators being all the same, we can just equate the numerators. So 1 equals to 2 sine squared theta plus sine theta. When you have something like this, when you have a squared term and a linear term and a constant, move everything to one side and get ready to factor the trinomial. This is where that factoring from grade 10 comes back into play. Don't know if you remember how to factor, but you should by now. This just becomes, and you do it whatever way you want, but I know it's 2 sine theta minus 1, and this is sine theta plus 1. Why is this helpful? Well, because, and this is like this chapter 4 stuff again, okay. Just make each of these parts equal to 0. So 2 sine theta minus 1 equals to 0. Therefore, if I were to solve this, I get 2 sine theta equals to 1, or sine theta equals to 1/2. And I know that this becomes, when I do these special angles, theta equals to pi over 6. Since sine is positive in quadrants 1 and 2, I know that my other angle must be this one, where that would be pi minus pi over 6, or 5 pi over 6. Don't forget to also solve the other bracket. So sine theta plus 1 here equals to 0. Sine theta equals -1. So that occurs, and this is the one where I like to draw out the sine graph. And I know that, hey, it must equal to -1 right here. That would be 2 pi. Middle would be pi, so halfway between would be 3 pi over 2. So there are my 3 answers. Done. Okay. All right, let's take a look at the next one. Cosine squared theta minus sine squared theta. Whoa, whoa, whoa. 2 trig functions. Don't like it. your job to try to change it into 1. Lots of different ways to do this, but for me, I'm thinking cos squared theta minus sine squared theta. I see that right here, double angle. So let's rewrite this as just cos 2 theta. And this becomes like a question from section 5.4. This is pretty straightforward to solve, I hope. We're going to take now the inverse cos of 1/2, and this is where you go to your special angle table and find, I believe, that this equals to, what is that? I think it's 60 or pi over 3. So this here becomes pi over 3, but wait, that's not the only answer. Cosine is positive in both quadrants 1 and 4. So this other angle is probably 2 pi minus pi over 3. Or that's just 6 pi over 3 minus pi over 3. 5 pi over 3. So ultimately here what we have, and you're going to need to solve this now, is that you have 2 theta equals to pi over 3, and you also have here 2 theta being equal to 5 pi over 3. Continuing with the one in green, I'm going to divide by 2, so you get theta equals to pi over 6. That's one of your answers. Continuing with one in the purple, that would be 5 pi over 6. That's answer number 2. Now remember, this is cosine 2 theta, so your period got shrunk by 1/2. So instead of expecting 2 answers from 0 to 2 pi, you should expect 4. How do I get the other 2 then? Well, remember how I told you that this period got shrunk by 1/2, so the period is now pi? So yeah, why don't we just keep adding pi to our answers to find the next set of solutions? Pi over 6 plus pi, well, that just gives you 7 pi over 6. So that is another answer. 5 pi over 6 plus pi, that's, I think, 11 pi over 6. Here's another solution that is less than 2 pi. So for this question, there are 4 solutions. Okay, let's turn the page. Some more examples, and this time I want you to try to solve these over the domain from 0 to 360, so let's just use degrees. So we've got 4 sine theta cos theta minus 1. Okay, sine and cos stuck together. Where do you actually see sine and cos stuck together? Go back to the front page. Where on that identity sheet do you see sine theta and cos theta stuck together? And if you said double angle, that's right. Now I'm just going to copy this onto our page 2. We had here sine 2 theta equals to 2 sine theta cos theta. Now I want you to understand something here, okay? The 2 theta is related to the thetas here, okay? The coefficient 2 is related to the coefficient in front of the sine 2 theta. Since it's not there, the coefficient is really just 1. So our example 2a problem doesn't really involve 2 sine theta cos theta. It involves 4. That's right, 4 sine theta cos theta. Which means if I want to write it as one trig function, how many sine 2 thetas are there? Well, you see how the 2 is the coefficient that's related to the 1. So now if I doubled it, I better double the coefficient over here. So it becomes 2 sine 2 theta. Okay? This is the same thing as 2 sine 2 theta. Okay? That's pretty tricky there. So if you weren't too sure about this, spend some time right now to stop the video and mull this over. Okay? We'll continue now. And how we solve this, we want to isolate the sign. So I'm going to move the minus 1 to the right-hand side. So 2 sine 2 theta equals to 1. Going to divide by that 2, so sine 2 theta equals to 1/2. We're going to try to solve for 2 theta now, which is the inverse sine of 1/2. That's the special angle thingamabobber. Look at your table or something else, and you'll find that this equals to 30 degrees. Or, remember, all students take calculus, quadrant 130, and also, that's right, quadrant 2. Quadrant 2 angles are always 180 minus the reference angle, or in this case, 150. So ultimately here, what we have is 2 theta being equal to 30, and we also have over here 2 theta being equal to 150. Solving for theta in these cases, that's 15 degrees and 75 degrees. However, these are not the only solutions because once again it's sine 2 theta. So our period has changed. Instead of the regular 360 degrees, we're going to cut this period in half because it's a horizontal compression by a factor of half. And so our new period is, in this case, 180. So I better add 180 to all of these to get my second answers, or my second set of answers. That will be 195. And 75 plus 80, well, that's just 255. And I could add 180 again, but because the domain is only to 0 and 360, I better stop with these 4. Okay. All right, part B. Wow, sine squareds, tans, and cos. Yuck, 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 yuck. How about trying to get rid of some stuff or simplify? I'm thinking, yeah, tangent. Yeah, that's just sine over cos. So let me write that down. Sine theta over cos theta. And since I have a cos theta here, lovely, those just divide out. Okay? Left-hand side still sine squared theta. So now I'm thinking, let me just rewrite this again. I've got sine squared theta equals to negative root 3 over 2 sine theta. I know many of you are tempted to do this right now. Oh yeah, sine theta squared, cancel out. Please don't. The reason is if you do that, you're just going to eliminate one of the sine thetas and you would have lost an answer. So what I prefer everyone do is just move all the terms to one side and see if you can factor out what's common. Because once you move everything to one side and you have it equals to 0, seems like people just understand that, hey, I need to factor stuff out. And they do. So in this case, they'll factor out, for example, sine theta. And what you're left inside is sine theta plus root 3 over 2. And when you have this type of form, they know, oh yeah, either the first part here, sine theta equals to 0, or the second part here, sine theta plus root 3 over 2 equals to 0. Okay? So here we just need to solve for the one in purple, where is sine theta equal to 0. I like for these special numbers like 0 and 1, I just draw out what tangent looks like. I know it's 0 at 0, 180, and 360 degrees. So theta in this case is 0 degrees and also 180 degrees. I'm not including 360 because if you look at the restriction from up top, it's just less than 360, not less than or equal to 360. With the other one, I know that sine theta must equal to negative root 3 over 2. Special angle table of root 3 over 2 is a reference angle of 60 degrees. But because this is negative, once again, all students take calculus. Because it is negative, we need to use, I think, our answers in quadrant 3, which would be 180 plus 60, which I think is 240. There's one answer. I should box these other ones. And our answer in quadrant 4, which would be 360, take away 60. And that would be 300 degrees. Done. Okay. Last but not least, example number 3, I'm going to ask you to solve these equations once again algebraically, but this time, instead of giving answers between 0 and 2 pi, I want you to give the general solution. Yes, that plus 2 pi n thingamabobbers. Okay? Alright, so I'm going to ask you to try these because I think I've given enough examples to kind of help you get going here. So I'm going to be quiet on 3a. I'll solve it, but I hope you can do it yourself. Okay? Go to it. Notice I changed the double angle into 2 sine theta cos theta. Then my lovely F word that I love to use, yes, factoring. Factor out the cosine theta. Now it's time to make each of these equal to 0, so cos theta equals 0. 2 sine theta plus 1 equals 0. Solve them individually. Like I said, with the zeros, I'll just draw out the cosine function. I know it's equal to 0. What's that? Pi over 2, 3 pi over 2. So in this case, theta equals 2 pi over 2, and also 3 pi over 2. And it keeps going, going, going. So the general solution, you can write this as pi over 2 plus 2 pi n, where n is an integer, and also 3 pi over 2 plus 2 pi n, where n is an integer. Or if you want to combine them together, I guess you could have also written it like this. Pi over 2, and instead of adding 2 pi, I'm just going to add pi n. That works as well. Okay, but you don't need to actually do that in blue. I would calmly and correctly accept your answer if you wrote what you did in red. Okay. All right, the other side, got to solve that too. Don't get too excited, you're not done yet. 2 sine theta equals -1. Sine theta equals -1/2. Doing the inverse of sine of -1/2. What do we get? Half is 30 degrees, so this is 30 degrees, but it's negative. Once again, quadrants 3 and 4. I'm sorry, we're doing radians, so it's not 30 degrees, it's pi over 6. Pi plus pi over 6, that's 7 pi over 6. So 7 pi over 6 plus 2 pi n, where n is an integer. There's another solution. Also, quadrant, I think, 4, right? All students take calculus. Quadrant 4 angles are just 2 pi minus pi over 6. 2 pi is the same thing as 12 pi over 6. 12 pi over 6 minus pi over 6 is just 11 pi over 6. That's my first solution. Going to add to that 2 pi n. There's my other general solutions. Those 4 things in the clouds are your final answer. Oh, I'm getting tired here. You do the last one. Cotangent. Yes, rewrite that as 1 over tangent. Just like example number 1. Find the common denominator. Just like example number 1. Then equate the numerators, just like example number 1. Then move all the terms to one side, just like example number 1. Then employ Mr. Lee's favorite F word, factoring, just like example number 1. By the way, use whichever method you like here, okay? Then, since these equal to 0, solve each of the brackets individually. For tan theta minus 1 equals 0. That just means tangent theta equals to 1/4. Oh, solving this is kind of weird because it's not a special angle. Gotta bring out your calculator. Gotta make sure you're radian mode, and in this case, take the inverse of tangent. Inverse tangent of 1/4 equals to 0.2449. I'm just going to round this to 0.245. 0.245. This is a positive angle in quadrant 1. All students take calculus. Must be in quadrant 3. So that means I have to add pi. So pi plus 0.245 is my other solution on the calculator, plus pi. I get here 3.387. Okay, these are radian answers. That's for the first bracket. There's still one more. Whoa. Equals to 1. Inverse tangent of 1. This one I know because it's a special angle. That's just pi over 4, so I'll keep it in that form. This is still positive, so once again, 1 in the third quadrant. So pi over 4 plus pi. That just equals to, I think, 5 pi over 4. And what do my tutoring students would always say after this? We're done. And I'll say, no, you're not. You didn't read the instructions. And then she'll go, woof, woof. Don't understand why, but just reminded of that right now. I guess she's pissed off. But in any case, please go back and read the instructions, because I don't want you to get mad when I take off marks on your test, because you just forgot to read the instructions. What do the instructions say? Give the general solution. So with this now, please write down the general solutions. Now, because tangents, if you notice, the period is pi, you only really need to take one answer and just say plus pi n, where n is an integer, because that will give you the 3.387 and all the corresponding ones from that. Same thing with the other one here, with the pi over 4. I can really just go plus pi n, where n is an integer, and that takes care of all the solutions as well.